ப்ரொஃபசர்.
ஆ,
அதை வந்து நீங்க மாரிசன் பாய்டு ரெஃபர் பண்ண சொல்லியிருந்தீங்க.
ஆமா.
அப்போ நீங்க வந்து அந்த ஹை டெம்பரேச்சர்ல வந்து ஹீட் பண்ணும்போது அசைல் குரூப் வந்து நமக்கு ஆர்த்தோ போகுது அப்படின்னு சொல்லும்போது மெட்டா கிரஷால்ல நீங்க அந்த மெத்தில் குரூப்புமே வந்து ஷிஃப்ட் ஆகிற மாதிரி காட்டியிருந்தீங்க. பட் மாரிசன் பாய்டில் வந்து நீங்க ரெஃபர் பண்ண சொல்லும்போது அதுல மெத்தில் ஷிஃப்ட் ஆகலையாங்க ப்ரொஃபசர்?
மெத்தில் ஷிஃப்ட் ஆகாது. மெத்தில் ஷிஃப்ட் ஆகிற மாதிரி ஸ்ட்ரக்சர் ஒன்னுல இருந்து இன்னொரு இடத்துக்கு போறப்போது
ஸ்டார்ட் பண்ணிடுறேன் சார், சொல்லுங்க.
Hello, sorry for the interruption. Can you repeat the question? என்ன கேள்வி உங்களுக்கு?
ப்ரொஃபசர், மெத்தில் குரூப் ஷிஃப்ட் ஆகிறது மாதிரி ஸ்ட்ரக்சர் வந்து நம்ம டிஸ்பிளேல காட்டியிருந்தீங்க ப்ரொஃபசர். தட் இஸ் மெட்டாக்ரஸால்ல அசைல் குரூப் ஆர்த்தோ பொசிஷனுக்கு ஷிஃப்ட் ஆகுது. தட் இஸ் தெர்மோடைனமிக் ப்ராடக்ட் அப்படின்னு சொல்லி நம்ம பார்த்துருந்தோம். அதுல வந்து அந்த ஃபீனாலிக் ஓஹெச்சோட மெத்தில் வந்து மெட்டா பொசிஷன்ல இருந்திருக்கணும். பட் ஸ்ட்ரக்சர்ல வந்து அதுவும் ஆர்த்தோக்கு வர மாதிரி இருந்தது. அதுதான் வந்து எனக்கு கொஞ்சம் கான்ட்ரவர்சியா இருந்ததுங்க.
அது ஆர்த்தோக்கு ஒரு பொசிஷனுக்கு தான் போகும், ரெண்டு பொசிஷனுக்கும் போகாது. என்னுடைய இது எனக்கு கரெக்டா அந்த ஸ்ட்ரக்சர் முன்னாடி இல்லை. ஆர்த்தோ ஷிஃப்ட் தான் பாசிபிள், நாட் மெட்டா ஷிஃப்ட்.
எஸ் ப்ரொஃபசர்.
ஐ திங்க் நீங்க இதுல பாத்தீங்கன்னாக்கா மாரிசன் அண்ட் பாய்ட்ல ஆர்த்தோ ஷிஃப்ட் தான் போட்டிருப்பான். ஆர்த்தோ ஷிஃப்ட் இஸ் தி ஒன்லி பாசிபிள். நான் எதான கிளாஸ்ல சொல்லியிருந்தேனுக்கு ஐ எம் சாரி, இட் வாஸ் ராங்.
நோ இஷ்யூஸ். தேங்க் யூ ப்ரொஃபசர். எனக்கு அது கிளியர் ஆயிடுச்சு இப்ப.
யூ ஆர் வெரி வெல்கம்.
எஸ், தேங்க் யூ ப்ரொஃபசர்.
வேற யாரான क्वेश्चन இருக்கா? Hello, chemistry master Vidya Bharati and Ravi. Do you have any questions? You have welcomed me and I am
Professor.
Yes.
Professor, I am Vidya Bharati Ravi. Just now I talked to you, Professor.
Oh, okay.
நீங்க சொல்லி கொடுத்துட்டீங்க. Thank you, Professor.
Okay, thank you.
Yes.
Ms. Gopika, you registered as a guest. Do you have any questions? If there is no further questions, I will just spend some time to go over the subject we saw in the class. Various videos. The first part of the course is based on phenol and its compounds. Phenol is a very different class of compounds compared to other organic compounds. It has a hydroxyl group like alcohol, but in phenol, the hydroxyl group is more acidic because the benzene ring is electron withdrawing. It pulls the electron between carbon and oxygen and makes it very acidic. If you have different type of substituents in the phenol, the acidity is modified. For example, if you have cresol, which is a methyl phenol. You can have ortho, meta, and paracresol. In all the cases, the acidity will be reduced because methyl group is electron donating. On the other hand, if you have very electron withdrawing group like nitro group, if you have paranitrophenol, orthonitrophenol, etc., the nitro group being electron withdrawing will push the electron towards away from the hydrogen towards the oxygen, and the hydrogen will be more easily given up as proton. Therefore, the acidity of these nitrophenols will be much higher. Now, phenol is a very important compound which is used extensively in various chemical processes and also in physical processes like cleaning, etc. You would have heard about phenyl. It's a suspension of phenol in water, which is stabilized by adding some chemicals. And this is used for cleaning the bathroom, the regular floor, the kitchen, and the living room. Now, because it is such an important large-scale requirement for the phenol, it is manufactured in large quantities by chemical industry, and the most earliest procedure for preparing phenol is called the Dow process. This is produced. This helps to produce phenol by reaction of chlorobenzene with concentrated sodium hydroxide at very high temperature and pressure. Then you can neutralize and get phenol as the main product. There is also a method of reacting phenol with sodium and the H2SO3, and the resulting compound is fused with alkali and the corresponding benzene sulfonic acid with a high temperature and pressure. This process is not used anymore. There is a third process, which is called the cumene hydroperoxide process. This is the most modern process that is being used, mainly because it is very energy efficient. You don't heat it to high temperatures or pressures. This is done by using the cumene, which is an organic compound which is reacted with oxygen, and then this is rearranged by treating with acid. The phenol is also prepared in the laboratory, especially with specific substituents. If you want to have phenol with a methyl substituent in the meta position or in the para position, this cannot be easily done with the industrial process listed. This is done by using a process called diacetization and reacting with water. When you take an amine and react with sodium nitrite, it will form the diazonium compound. This is then reacted with the corresponding water plus acid at a slightly higher temperature, and the amino compound, that diazo compound, becomes the phenol. Phenol is very soluble, about 9 grams in 100 grams of water, and it is also having a lot of intermolecular hydrogen bonding, and because of that, phenol is very highly boiling. The temperature of boiling is very high. And the phenol forms ester with various compounds like the sulfonyl chloride, aromatic acid chloride, etc. It also forms electrophilic substitution. These are reactions in which phenol reacts with E plus, an electrophile, and it gives the corresponding substituted compounds, like, for example, nitrophenol, phenol with SO3H, the halophenols, nitrosophenols, etc. And they are very important substitution product of phenol and makes it very efficient in producing a large number of phenolic compounds for various types of uses. A large number of these uses also are found in pharmaceutical industry. Several of these phenolic compounds can be substituted with acetic anhydride or other types of anhydrides to form the corresponding compound, which are having very important pharmaceutical applications. Now, in addition to this phenol, we go to next to the carbonyl compounds. Carbonyl compounds contain C double bond O as the main substituent. And if you have the C double bond O, where only 2 carbons are attached, this is called ketone. If you have 1 alkyl group and 1 hydrogen, this is called aldehyde. These are also very important compounds. Whole variety of products are made from the ketone, and the ketones are extremely useful in getting both oxidation products and reduction products. If you take aldehyde and you oxidize it, the common reagent is used, it's called the tolerance reagent, and this will produce the corresponding acid. If you take a ketone and oxidize it with potassium permanganate, it will form the corresponding carboxylic acid. If you have 3 carbons, it will form a carboxylic acid containing 2 carbons, CH3, COOH, the acetic acid. The important next is group of compounds in organic chemistry is acids, carboxylic acids. Its structure is C double bond O OH. The carboxylic acid represent a very important compound. It can be used to produce a large number of pharmaceutical compounds. The most important pharmaceutical that is produced is salicylic acid, C6H5OH, COOH, ortho hydroxy benzoic acid. This is used as a painkiller. Now, the variety of carboxylic acid compounds are available, and they are very useful. The acidity of carboxylic acid, just like phenol, is based on the attachment of groups in the molecule where phenolic groups are, the carboxylic groups are present. If you have a carboxylic, let us say CH3 COOH, that is acetic acid, if you attach chlorine to the methyl group, you will get Cl CH2 COOH. Because chlorine is electron withdrawing, it will pull the electron away from the hydrogen of the carboxyl group, and it will form the, it will make it very acidic. If you add more such groups, instead of this, you add nitro group. The nitro acid is very acidic compared to the chloro acid. So we have different acidities, and you can arrange these groups in order of acidity based on the type of groups that are attached to the carboxylic acid group. Now, you have also nitrogen compounds, which can be classified as nitro compounds and amines. The nitro compounds are usually prepared from hydrocarbon, aromatic hydrocarbon, by reacting with nitric acid and sulfuric acid at high temperature, around 120 to 160. So if you have a simple reaction with the benzene and nitric acid and sulfuric acid, you will get nitrobenzene. When you try to further nitrate the nitrobenzene, it doesn't react very readily because the nitrobenzene is much less reactive compared to benzene itself. If you use, instead of the regular reagent, if you use the fuming nitric acid and fuming sulfuric acid, the nitration will go to add more nitro groups. You will get meta-dinitrobenzene and 1,3,4-trinitrobenzene. The 1,3,4-trinitrobenzene is referred to as TNT. It is one of the important explosive compounds. So large number of these nitro compounds can be prepared by proper use of the reagents that are necessary for the introduction of nitro groups. The nitro groups on reduction gives the amino groups, and you can see that if you have one nitro group and reduce it with the tin and acid, you will get aniline with one NH2 group. If you have two nitro groups and you reduce it, you will get meta-aniline. You have aniline in 2 positions, 1 and 3 positions. If you have 1, 4, 6, you will get amine in 3 positions. So these amines are very important, again, pharmaceutical intermediate, and they can be easily reacted with CH3COCl, acetyl chloride. The acetyl chloride will react with amine to form the corresponding the acetyl derivative. So you can see the large number of compounds that are produced by various type of reactions, starting from the phenol phenolic compounds, then carbonyl compounds, then carboxylic acids, then the nitro and amino compounds. Mr. Charan Del Bhaskar, do you have any questions? The amino compounds form a very interesting group of compounds. They are reacting easily with sodium nitrite and HCl at about 0 to 5 degrees to produce what is called azo compounds. The structure will be C6H5NH2 is the amine. The resulting compound after the treatment with nitrite and sulfuric acid or HCl, you will get C6H5, N, triple bond N plus Cl minus. These are referred to as azo compounds, and the great tendency of these compounds is to react with the phenolic compounds like naphthol, hydroxy attached to a naphthalene ring. And usually these reactions take place when the naphthalene is converted to naphthol with sodium hydroxide. And the azo compound can react with this again at 0 to 5 degrees because of the instability of the azo compound. When they react, they form very nice colored compounds. The simplest compound is this phenyl azo naphthol. This will produce an yellow type of dye. If you have more substituents which are electron donating, you will get increased colors starting with orange, blue, green. So these are the very important azo dyes which are produced for applying it on fabric, the compounds which are soluble and colored are referred to as dyes. These are applied to fabrics, usually the cotton, and some of them are also applied to wool. If the dye has a lot of sulfonic acid group, SO3H group, the resulting dye will be applied to the wool. This is called acid dyes for wool. So you have a variety of azo compounds which lend themselves to dye both cotton and wool. And this is a very important part of the chemistry of amines. There are other amines which can produce various types of compounds, colored compounds. One more thing is that when these compounds are not soluble, they are called pigments. They are not dyes, they are pigments. These are the compounds that are used when it is formulated to produce paints, to protect the walls and other surfaces. So pigments are very important part of the chemistry of azo compounds. Both dyes and pigments are extensively used for the purposes for which they are produced. If you have no further questions, the session can be closed. I will answer this question. What about pigments in nature? In nature, the pigments are produced especially by flowers which have compounds called anthocyanins. These anthocyanins have colors usually starting from yellow and becomes orange and sometimes red. These compounds usually have antioxidant compounds present in it. These antioxidants which produce what is called the chromophore. Chromophore is the chemical that is responsible for absorption of light. When you have white light and is absorbed selectively because of different chromophores, these different compounds are produced, and these produce various types of colors. And these are very important compounds, especially they are used now in most of the natural drugs. And this is a very important antioxidant, and therefore it has become very important now. The phenol has a very pungent aroma, and if you reduce the concentration by adding water, then the aroma becomes moderated. It is not as pungent as before. The human eyes have different type of pigments, and these pigments are present in the retina, and this retinal pigments is the one which is responsible for our sight. What happens in the retinal pigments is having a change in the structure of the chemical as light is entering into the eye. These compounds have cis and trans geometry, and when light is entering, the cis compound changes to trans. And when that happens, that is the main reason for eyesight, because when that happens, the length of the molecule increases or decreases. When the length of the molecule increases, it gets into the optic nerve and pushes it close to the retina. And if the compound is not available in sufficient quantities, there is not enough material to push to the retina, and the eyesight is affected. And also these compounds are also responsible not only for just modulating the eyesight, but also the color perception. The color perception is also due to the wavelength of absorption of the light, which is cis compound versus trans compound. I am just using the word cis and trans because the molecule is very large, and it has a lot of other stereocenters, and it is difficult to depict on the board here. So these compounds are very, very important for eyesight, both the eyesight itself and also the color perception of the eye. They call it rod and cones. The rod and cones are differently sensitive to light, and this different sensitivity is incorporated by the trans and cis compounds that are present in the eye. If you add a cumene to phenol, it won't directly form. If you add cumene, oxygen with the cumene, phenol will not form directly. You need an acidic medium because the oxygen attaches it to carbon atom and forms what is called a hydroperoxide, COO. This COO will undergo rearrangement to give phenol only if you add H plus, some kind of acid, preferably HCl. Once the HCl is added, the OOH is protonated at one end, and because of this protonation, the carbon moves to that particular carbon atom which is protonated and gives the phenol. The antioxidant properties of phenolic compounds comes from the fact that phenol has a great tendency to react with oxygen. You will find whenever you purchase phenol or keep phenol in your house, which I don't recommend because its toxicity is quite large. This used to be kept at home in the earlier days because phenyl was prepared in household earlier. When you have phenol, some amount of oxygen enters the phenolic molecule, and you'll have it become a slightly brownish liquid in the beginning. As the oxidation proceeds further, it will become almost a black liquid. So the structure may not be changing very much because these are just compounds which are present in just small amount and still produce a lot of color. If you, for example, distill some of this black phenol or brown phenol, you will get more or less the same amount as the distilled phenol. Now the distilled phenol will be colorless because it is not exposed to air yet. When it is exposed, it will again become colored. spend some time on the pharmaceutical industry, which is based on the chemical industry. And the type of compounds that we have looked at, namely phenol, acetone, and acetaldehyde, and also acids, carboxylic acids, and the nitro and amino compound. All of these compounds are sources of a large number of the allopathic drugs. Allopathic drugs have known to be very effective in large number of disease states, either to ameliorate this condition or to cure sometimes, mostly for amelioration. In this case, generally there is also a feeling that these drugs have a lot of side effects. It is true that all these allopathic drugs have side effects, and these side effects can be modulated by adding other chemicals or decreasing the doses, etc. And there is a general feeling that other type of natural drugs are far better for this purpose, but one has to be very careful in coming to this conclusion, because the naturopathy or natural drug also has side effects, and in fact some of the side effects may be just about as bad or as good as the chemical compounds. But it is very important to realize that some of these allopathic drugs are life-saving. If you don't get these type of drugs in time, when there are certain disease situations, the condition may become fatal. There is a question about pigment color of the iris and the color of the animals. I don't know the pigment, iris pigment. I don't know what the color is due to. I don't think there is any connection between the color of the iris and the color of the animals by themselves. The antioxidant drugs or chemicals is touted as a very important health improving chemical. It is sometimes can be helpful because you get the important types of toxic materials in the body due to production of free radicals. The free radical is one of the most important byproducts of a respiratory process. It is the free radical that is capable of producing a lot of oxidative damage in the body. If you have antioxidants which can capture the free radicals, which usually they do, then the concentration of these free radicals will be less, and the damage to the tissue will be less. When free radicals are produced, it tries to combine tissues, amino acids, DNA. So it can lead to very significant damage if not properly handled. And I don't know if what is the correct allopathic treatment that is given for this type of situation where there is excess free radical. The excess free radical usually comes from large amount of sugar that is consumed, and also because of the problem with respiration for some people. there is a exploration of my answer about antioxidants and allopathic vitamins. Like for everything, the problem is the selectivity of the particular compound for reaction to produce reduction of the free radicals. The free radicals can be captured easily by certain type of structures, which has a very easy ability to get oxidized. And the vitamins do form the core of antioxidant therapy, but there are certain situations where the free radicals will be of much higher concentration, and it needs to be addressed with compounds more effective than vitamins. There is one more question added by this person who seems to want to prove that I don't know enough. Fruits and some seeds are also used as antioxidants, as almost everything that is present can have certain antioxidant property because they are able to get oxidized. When they are able to get oxidized, something that is introduced which needs to be oxidized, so they will function as antioxidants. It's very interesting that we had such a lively exchange, and I hope people will go away with taking some of the important ideas that have been presented here. And it has been a pleasure to prepare and offer this course. Of course, I'll have one more session where this kind of live discussion can be held. The date has not been fixed yet, and it will be put on the portal. So it's very pleasing for me to be present today to participate in this live session, and I thank you all for offering pearls of wisdom through your questions. Thank you. Thank you for your response, Sharan L. Bhaskar. I'll try to arrange that pen and page discussion for rearrangement. Then in the next live session, I'll put the time on the portal.
Thank you, sir.
Thank you very much, and I'll look forward to having you again with interesting questions like this in the next live session.